Hello everyone, it's still Winter Data Meetup and our next speaker is Shiva Achari, who is a big data solution architect in EPAM, and he will talk about very interesting topic, data lakehouse. Let's learn more about this architecture. Please don't forget to ask your questions in YouTube chat. Shiva, floor is yours.
Thank you, Alexander. Yeah, hi, good morning, everyone, or in different part of world if you are, or good afternoon or good evening. Welcome to this data lake architecture pattern. I will be the host. I will be talking about this architecture. Be as interactive as you can. If you have any questions, please post it in the chat. I'll be able to respond as I go, and I will be able to respond to you at the end of the presentation. So let's talk about data lake architecture pattern. So this is my introduction. Uh, so I have total 15 years of experience with a decade in data and analytics system. So I joined EPAM 4 months back. So I work as a data solution architect currently. I was working with AWS as a data lab architect, and before that I was working with Hotstar, which is acquired by Disney Plus, as a data architect, technical architect in India. And I'm an author of a book, The Hadoop Essentials, which is by Pact Publication, which is based on Hadoop and ecosystem components. You can look at it. And I'm also author of blog post on Spark SQL based ETL pipeline on which is live on the AWS blog post. And I'm very active in LinkedIn. So if you guys are interested to connect, please feel free to reach out, and I will be more than happy to connect with you guys. So let's look at the agenda for today. Today we are going to cover some the introduction part of data warehouse, data lake, where we will be covering introductions and the components which are involved in data lake. Data lake house will cover introductions and approaches of how data lake architecture is designed. Data mesh. Data mesh will be purely introduction. We are not going to talk about the implementation part of it. We'll just introduce the topic and question and answers. The intention is to have the audience understand the difference. Each of this architecture are well suited for a specific use case. The intention or the outcome for this talk would be to help you understand this distinction, which architecture to use where. So if I ask anyone, like, let's start with the most important thing, uh, which is data growth and trends, which are the prime reason why we have different architecture that we are going to discuss, right? And in this slide, we have the infamous article by The Economist, which was 2017, which, and especially the quote, like, the world's most valuable resource is not oil, but data. This holds true. We know data is a strategic asset for every organization. Data has gone from being something that was cumbersome and expensive to store to becoming the lifeblood of many of the company's business model. Companies today are using data to drive decisions like when to offer new product offerings, how to introduce new revenue systems, and automate manual processes, how to earn customer trust. This is very, very important. Many use cases work around personalization to earn customer trust. All these decisions are fueled innovation and to drive your business forward. And it is the core part of its data. We hear from companies all the time that they are looking to extract more value from their data, but struggle to capture, store, and analyze all the data generated by today's modern and digital business. Data is growing exponentially, like coming from a new source. It's increasingly diverse and needs to be securely accessed and analyzed by a number of applications and people. Data is the core behind every business and every decision. So this is our first topic, which was the analytics. Traditionally, analytics used to it looked like this, like from OLTP system like ERP, CRM, LOB, all of this system data was pushed to a data warehouse, and it is visualized by the business and intelligence systems. Uh, some characteristic of data warehouse uh, specifically are like data was completely only relational and structured. Uh, it can scale up to terabytes of and even max to petabytes, not beyond that. Either it will be not able to scale or it will be very expensive. Schema has to be defined prior to data load in data warehouse. This is a significant block in terms of adoption, and it takes a lot of time. It is ideal for operational and ad hoc reporting. It still is ideal for operational and ad hoc analytics. It is not like it has gone out. Data warehouse still, I would say, in most of the use cases are very good for ad hoc reporting or operational reporting analytics. Another important characteristic of data warehouse is it has a large initial capex, which means the company has to pay uh, or like upfront, like, and it is not often, most of the time, it is not proportional to the usage of how they're using the data warehouse systems, and they are expensive, uh, need to be taken care of. And why suddenly to go out from data warehouse? Some of the things that triggered over the past 5 to 7 years, a couple of key trends have got us to this point. So we have got various devices now, connected devices, apps, and systems now generate more data than ever before. Like as per statistical reports, data grows more than 10 times every 5 years. Like data platform migrations are not easy. Like data migrations are very difficult decision. It takes a lot of time and effort and money, and not easy to build and test. So it has to be designed for at least 10 to 15 years kind of state. And data growth and scale has to be supported by the data platform, and that is why there are different architecture that we're going to discuss today. With the improvements in the data analytics like machine learning and AI tools, and technologies have significantly improved, so we see more personas or user profile wants to access the data and derive insights from the data. Also, the requirement for data platform are more complex. So, as platforms should be able to ingest a variety of data. When we talk about variety of data, you're not only talking about structured data, you're talking about semi-structured data or unstructured data like videos, audios, your chat information, emails, or various other things will come into categories of semi-structured or unstructured data, and we have a lot of sources where this data variety of tools are captured. Platform has to be flexible, scalable. Scalable is very important. As the we see the data growth is increasing, the platform has to be scaling as per the requirement, as per the organization growth or the data growth axis of it. Some system require near real time or real time access, right? So these are some of the characteristic or some of the requirement which for which like traditionally data warehouse were now designed to the variety of data set and scale, on the scale that we are talking about on exabyte scale, not on petabytes, but many organizations are having exabytes amount of data collectively, and they want to do analytics on those data set. Due to this limitations, data lake architecture was designed, right? So we'll talk about that data lake architecture. So I just want to understand the audience better. So I have a question, and you will be able to see in your the platform the question and the answers. Right. So please uh, answer this from my understanding. So what is your current role? Yeah, Alexander, you
Looks like a half data engineers, and we have a little of uh, architects, 10% of architects and team leaders.
okay? So majority are data engineers and
Mhm.
architect in that category. Okay, good to know. So I will use this information to align myself and emphasize on some other topics which the role will be more interested in. Okay, okay. So let's talk about data lake. Like, what is the data lake as a concept? Like, data lake uh, is a centralized repository of data that allows you to store all of your data. It's the underlying word is all of your structured or unstructured data, no matter the scale. At any scale you can store your data as is without having to first structure the data and run different type of analytics, like from dashboards or visualization to big data processing, real-time analytics, and machine learning to guide better decisions. So some characteristic of data lake are like you are collecting, ingesting, ingest and store to store structured like a variety of data that we discussed, like at any scale, and more importantly, it should be stored at low cost. Data stored should be searchable and discoverable in data catalog, which holds metadata about the data, and this data catalog acts as an interface for discovering and accessing the data. We will look at an example of that. Another characteristic is to decouple storage and compute to achieve independence in storage, like and compute to enable different analytic tools to integrate without data movement. So data need should not be moving around this platform. The core piece, the data underlying data should be available in data lake, and different analytical tools should be able to integrate and access that data rather than data movement or loading the data into the system. We will avoid or limit those kind of movement. Storage should be durable, available, it should be scalable up to or beyond I would say exabyte scale. uh, you it is it should be supported to run different type of analytics. It should be integrable to different set of tools from like data warehouse, machine learning, AI, predictive analytics as well are very common or very requirement for organization. The architecture has to be flexible and integrable to other analytical system. These are some of the characteristic of a data lake. So there is no formal definition to a data lake for, or it's a approach or it's an architecture, and these are the characteristic that guides us to build a data lake. So when we talk about data lake, all these attributes should come into picture, not one or two. It is all of them needs to be there. Then we should call that as a data lake. So let's look at, I just wanted to, this diagram would depict components in data lake. I'm taking AWS as an example, but you can, it is applicable for open source and other clouds as well, the similar architecture. So at the core of the data stored is central storage, which is S3. If you're familiar with AWS, we have it S3. In open source, Hadoop, we have HDFS as the store. The data ingestion is the first layer which will read the data from sources and store the data into the data lake. So this is the ingestion layer. So some of the services within AWS I've depicted, like you have Kinesis data firehose to store the batch data. You have Kinesis data streams, which can ingest the streaming data or near real-time system. We have database migration service to load the data from OLTP system or RDBMS system. Uh, you have storage gateway to read the data from a specific gateway, like specific drive or specific hardware. A direct connect, like where you connect to a different cloud or a data center accordingly. You have Snowball as well, as in data ingestion tool. This is the first component. Once the data is loaded into, uh, iteratively the data should be cataloged, it should be searchable, and it should be available in a catalog. For example, Elasticsearch or OpenSearch, I would say. OpenSearch is a tool which is open source, and it is a new version of the new fork of the Elasticsearch, which are open source now, which will make the data within your data lake searchable if you integrate those. There's a Glue catalog, which is comparable to your open source if you're familiar with Hadoop, which is Hive, Metastore, but it is like which will you can consider that it holds the metadata of all your data lakes or data stores, as well as the access, who has access to what, to that, like granular level on that. Glue as another piece of ETL, that is a different topic, but this we are considering calling out data catalog service within AWS for integrating. As we discussed, this catalog is extremely important, and it is an interface that will be used for different tools or in this layer itself, which will integrate via the data catalog. So this becomes a central piece or very core piece in the data lake architecture. Once we have done this, the data management and security is also very, very important in any data world. Like you're talking about, uh, like storing the data in encrypted form for security and audit purpose. You will want to monitor your data set. And so manage and security services needs to be enabled on this data lake for operational perspective. Then comes, this is the most interesting, or most of the users would be familiar with this analytical serving tool, like which is, there are different type of analytics tool which I'm trying to depict here. Like it's not only one, and data lake or the data which is there in S3 are integrable to different set of processing or analytic serving layer, like Athena, if you're familiar, Presto like, which can run SQL query on the data which is there on S3. EMR is your Apache Hadoop version itself. You have Glue for ETL processing as well, QuickSight for visualization layer, Kinesis for near real-time processing, Redshift is the data warehouse, DynamoDB is a key value store within AWS, Elasticsearch are open source service, Neptune is the GraphDB, RDS is the OLTP. So if you look at it, in the data lake is set up, or S3 is uh, structured in a way where it is integrable, and the interface that is between is the data catalog and the access permission management as well. So rather than moving the data into the system, it is accessing the system, uh, which is a drastically different approach, and it saves a lot of time and effort uh, of different teams. Like you will have different team need access to different kind of analytical tool, rather than working on data movement or loading the data into the system. If you are able to integrate and access the data, verify whether this data model is the right fit, so it gives you a lot more option in terms of ad hoc analytics or processing, and make sure that your whatever analytics or idea that you have in mind are working correctly as per expectation. Then for interfacing access and the user interfaces that we call as you can have access to this data securely using gateways. You can build APIs to access those data. Cognito can be user-based interface from mobile for mobile devices or user authentication. AppSync can also help in enabling access and like sending the data to syncing the data into different multiple devices and all of those stuff. So as you can see, you as a data lake approach, it's not one service or one part. It is a combination of all of these pieces that come in shape to build have this data lake architecture to be built. So as an architecture, when we call as a platform, all of this component should gel together as one. Okay. So yeah, this is another question which would like to say. So if you have an understanding of a data lake or you have worked on it, what does data lake mean to you? Like data store, is it supporting self-service BI analytics or a staging layer for other platform or single source for your analytical and operational workload or a data science sandbox, or is it a replacement for data warehouse? Just going through one question from James Bond. So I mentioned like many of the AWS service can be used for data lake. Can I implement data lake properly without learning deeply all of them? Yes, you need to this services you need to understand like different personas will be managing different layer. Like it's not one team or one system who will handle everything. So yes, there will be a data platform team who will govern this, but there can be another different team who will be managing this analytical services integration or access management can be different, security could be different depending on organization. Yeah, if you are in an organization where you do not have or you can have that skill set and you will have offload to that team uh, who can manage that specific thing. So technically I would say it is a combination of multiple roles of the team. It is uh, easier like it is like you need a team to build this data lake as well. So wait for 5 to 10 seconds till you answer.
Yeah, so we will collect answers a bit later. So
Got
let's
it.
move on.
Let's move on. The second architecture that we have today that we are going to discuss is lakehouse, data lakehouse architecture. So we looked at two architecture like data warehouse. We have a fair understanding because it has been for a longer time. We have seen data lake. Both have their advantages and disadvantages. Because data lake also has like it requires it's a different architectural principles, guidelines, technological skills which are required, which is different than data warehouse. So there is a learning curve and how it manages. It works on the actual raw data set, right? So where uh, and you are working on different layers to get the best of both of these. Like like since I'm already mentioned, like data warehouse is also is significant now as well in this part of world. Like we can see for reporting and other access, data warehouse is a very good choice. To get the best of both of this, the lakehouse approach or architecture have come into picture. Like some of the trends driving the architecture are enlisted. The reason, like the new data sources, we talked about the similar trends in data lake as well. It's not very different, like empowering personas, use the best fit analytic, growth in open data formats. Now you see a lot of different data formats, like Parquet, uh, ORC, which can be used for structured, but it takes it to a different level itself, where you can analyze the data rather than scanning all of those record. You can just scan a specific columns that you're using, which is very common. And it is like a columnar data format, and which is widely used in this part of data lake world, like streaming data analysis without loading it first, single source of truth, unify analytics, unified security compliance. Like these are some of the trends, and the reason why it is a significant amount of time, effort, and money goes in re-architecting or and data ingested to and from different platform. Uh, Hence, lakehouse architecture makes a lot of sense. We're gonna see of how we are talking about why we are saying so. Why am I saying so? So benefits of lakehouse approach, like we talk about, we like we are looking at a scale of using the data warehouse and data lake in tandem, like along with side by side, where it should extend from terabytes to exabyte scale with low cost. Security is very important. We should empower the personas. We should be loading any type of data and analysis. We should The critical word also is democratize ML with SQL, they would not need to require ETL or some other tools. So different personas has a different requirement of the tools. Like some of the business analysts would be familiar, like very competent with SQL. Some of them will be uh, competent with AI services. Some of them will be needed like a key value store kind of requirement. So different personas, different uh, integration requirement. So here's my honest approach to depict how lake house integrates the high level in a high level component. The key point is to not transfer the data. uh, and if there would be some data transfer required, but we would want to minimize that data transfer to and fro from data warehouse or data lake. As you see in the picture, there is already a data lake where you can keep the data. For example, we have seen that this architecture or this data can scale, and you are most of the time you're paying for as you're using. Like it's If you have that kind of data and you want to store that and analyze that now or later, you can store that in data, like it is very cheap. And then you have a data catalog, and then data warehouse on top of it. So data warehouse, if we look at in a way where data warehouse also integrated with data lake, and data warehouse acts as an interface or a layer where the BI and analytics apps are connected, so that your visual layer or analytics layer can be run via SQL. You can have ML integration on data warehouse, rather also, as well as in data lake, like depending on if and when we say ML integration on data warehouse, we're talking about ML integration which can be used via SQL queries. Uh, and also uh, it can be there are tools which can be also federating queries to operational database, querying live data. For example, you can have a data warehouse which can query the data from an RDBMS tool, and in a single query you are able to query the data which is there in data warehouse, as well as in data lake, in the operational DB in a single query. And that's how powerful this architecture can coexist. Like this is a powerful tool. The main reason is data lake, although it's everything fancy, everything goes on very well, the integration piece to BI analytics uh, needs to improve. And one of the best ways, utilize the tool which is already tested product, which is data warehouse. So another way to look at is how do we approach in uh, conceptually, how do we look at what is a data lake approach? Like what are the key benefits as well? So assume we want to analyze structured and unstructured data with minimal movement. Like we have a data warehouse that stores business data and a data lake that stores all the data. As we want to avoid or limit movement, we drastically reduce data swarms. Like data swarms are each individual team having their own silos of tables or structure, which are very common in a large organization. And over a period of time, there will be many such data warehouse tool licenses, which uh, uh, which they are baffled with in terms of why they needed. Like it can be overly simplified. So data swarms is a realistic problem in many big organizations where they have each independent team have their own data or data created in data warehouse, so they would have licenses and other costs. And most of the time, as I mentioned, the license costs are not directly proportional. It's not utilizing to that level as it used to be. It can utilize say max 50 to 60%, not beyond that. So we would for doing this, some of the things that we want to look at is we there can be other data sets in or like each in different team, like the business data, marketing team, sales team, who can have their own data warehouse. Like and how do we solve this problem of lakehouse? Like how do we want to do that? We can't get rid of this. The problem that we have is the data needs to move from one data warehouse to another data warehouse system. Like of marketing data would need to have data from sales and business data accordingly. The change that we want to do or enable in this data warehouse tool is to have no data copy, to have data sharing within or across this data warehouse, which means you let them have an independent data. The data would not be shared, and when we do this, we are no longer giving them a mandate like they need to copy this data and then duplicate the data, and each of this layer have their own version. They can easily access the data which is from marketing or sales or business data, whatever it is, without copying that data. So there's a single source of truth in this, and it makes a lot of difference in how that reducing data swarms. So capturing real-time insights via federated queries to transaction, like you will also ideally want to enable this data warehouse tool to integrate or access the operational analytics or real-time analytics system, the OLTP system, I mean to say, in a real-time fashion where they can live query on those data set. Also, if possible, it can be integrated to the third-party data, so external data set or platform that you may be organization may be using. Rather than moving the data in and out, you can either store that into a data lake, and if you cannot store that into a data lake, then access to from the data warehouse tool to this part is highly recommended. If you ask me practically, do we have a data warehouse which can do that? Yes, uh, um, AWS or Amazon as a tool, which is Amazon Redshift, which can do all of this piece, right from integrating to data lake to having a federated query to the OLTP system or RDBMS, and integration to ML as well as to external data source platform as well. Not all of them, but some of them. But it is a start to the journey or the process where data warehouse can become as an interface for all of your purposes. There is Snowflake as well, which has a very good integration to data lake and other uh, like uh, like some other features. Uh, so you can very well have a look and see if there are tools which you will prefer, which has this benefit for lakehouse approach. Hope this was clear. Due to the time, I would want to go a little further for the next. If there's any query, I'm more than happy to answer later after the end of the presentation. Okay. So the next architecture that I we wanted to discuss is popularly known as data mesh, right? It's not a architecture per se. It is an approach to building how we look at approaches of how to what all components are involved in data mesh, what is a data mesh, like like a data mesh is a socio-technical approach, which means it will align to as your current organization are. Each team will be able to have their own data products like data factory that we call as. We'll come to that. So we are going align with having the same organization feature, like how you are structured or hierarchy in your data, to build a decentralized data architecture by leveraging a domain oriented it is to be self-serve design in complex and in large, and it is very useful for large environment within or across organization in different multiple different countries as well. Like you have now a lot of regulations, so uh, you need to have such an architecture which can span across different geographies, and with compliance and all, it becomes more difficult. So data mesh is one of the approach to build such layers or data architecture layers. So conceptually, it is based on four core principles: domain ownership, like which are operational and analytical data, which involves domain bounded context design approach, like domain bound. So you are having a domain of and all the related data will be stored in that specific domain, and that's a kind of approach, and this is called as domain ownership. So there has to be a domain team who will manage these domains. Consider domain as a set of all the data set required for a specific entity, right? uh, like for a specific for a specific facts, or and some other dimensions related to that fact. Like data as a product, the second layer is data as a product. Data as a product acts as an interface which requires data, which acts as a which is managed by the domain team itself, and domain team will recognize what data needs to be accessed to outside of or to different domains, like which means they are making that data available for analysis or query. Okay, the third layer is self-serve data platform, which are domain agnostic, like, and are managed by data platform. Self-serve data platform means the team are independent, or like, rather than relying analytical team relying on uh, for example a table to be added or a column to be added. If the data is ingested, we have seen in data warehouse, like a single like even if the data is ingested, it has to be like you need to add the column, and then provide access and all of those feature. In self-serve, if the data is ingested, for example, you are loading the data from a source which is giving more columns now, like earlier it used to give 50 columns, now there are 55. uh, it is if it is We just need to push it into catalog, and once the data is in the catalog, the team who have and provide access, then the team would be able to read the data without any other engineering steps, like they are able to access those data set accordingly. So which is called a self-serve data platform. The fourth and one of the most important layer is federated uh, computational governance, and it is focusing on to manage governance managed by, so usually data stewards or security managers or data security managers. This is this principle will focus on uh, like uh, tightening the security, the data product that has been accessed, who has access to what, in what granular level. uh, just for example, there can be a data product which has PII columns, and not everyone in the organization would need access. So even though some would require access, so you have to publish that data set. Rather than duplicating, you can have a mechanism of data masking or redaction, right? And then you will be able to see a query, but you will not be able to actually see the data, what is the value. And it is useful in many of the compliance level masking you can set up. So this is how it is very useful. So data uh, mesh federates data ownership among data or domain data owners, which are held accountable for providing the data as a product, while also facilitating communications between distributed and data across different locations. Like this is an understanding of data mesh. So we talked about some of the concepts, right? Data domain and data product. So what do that mean? Because it is very important to understand. Uh, let's look at data domain. A data domain is a collection of, you can say, a team or a people which typically are organized around a common business purpose. Like you will have sales or marketing team, or a specific team, or who will be holding or managing those specific data set. Like there will be a team who will be managing that domain. And from the data management perspective, these people create and serve out data assets on full like oriented on fulfilling certain business need, I would say, use cases, which are independently from other domain. Like some feature that we want to have in data domain is data asset to be should be shared, like must be to be shared, or must be accessible, available, and meet the quality criteria defined. Data assets are evolved based on user feedbacks. Like domains are commonly organized around and aligned with data semantics, usage scenarios, and business capabilities. So when we talk about data products are the interfaces of the data output of some teams, like our system, to analyze the data within the organizations, or uh, most often it will not be external, but within the organization if we limit to that. Data product is an independently provisionable or deployable component. It is focused on storing, processing, and serving as data. So each product data should be implemented, evolved, or maintained by uh, actually by one domain team only. Uh, so if I have to talk about data product, like a data product is a data asset which is made available for broader consumption. Like it is supposed to be consumed, and it contains defined and monitored delivery contracts, which means uh, so even though the data is available, who has access to what, like whether it needs redaction, masking, or like if it is non-PII that can be sent, that kind of contract needs to be adhered, needs to be maintained in the federated layer as well. Aligned to domain business function goals, it is optimized for readability, and it adheres to organization governance policy and standard. So as we talked about, this all layer can be like managed independently, which means uh, if I look at the architecture, if I take a stab at explaining this architecture, the architecture will depict the four principles that we talked about: domain ownership, data as a product, self-serve data platform, and federated computational governance. These are the four principles that we talked about for the data mesh. Like within each principle there are policies or responsibilities that we'll look at. Like the domain ownership comprises of operational data, like data products on analytics, and data contracts for interfacing with other domains. So the other domain will be able to use this data contract, and then whatever data is published can be accessed by another domain. uh, so if we look at it, one domain can be in one geography, another domain can be in different geography. So the geography contracts and everything needs to be uh, like contracted or managed as a policy. The second is data as a product approach that we discussed. So when we talk about a domain, the domain product will be saying, okay, what all data are can be shared, and they will own that, and that is what we are going to publish. The third principle is the self-serve platform, which is at the bottom, where you say uh, it's a platform or responsibility to manage security and query engines, data catalogs, access management, monitoring, and policy automation are very very important for in this layer. Federated governance comprises of interoperability policy, documentation policy, like security, privacy, compliance, related contracts and policies. So if we look at it, all of these principles or layer can be loosely coupled, or has to be loosely coupled, I would say, which means each domain will be can be a separate uh, platform which is independent from the federated governance, can be separate from the self-serve data platform, can be and then it is enabling for this. So then you independently the team would work on, and data product acts as an interface for domain, and the contracts governance will be managed, and the platform data platform will be able to read all of this, who has access to what as a consumer, and according to that the data access will be there, or the data will be able to share across geographies. Although I mentioned it very in a simple manner, it could be a bit like challenging, because to understand so to design this is the approach, this is the first step. uh, this is, I would say, the zeroth step, not even the first step. First, to understand this, how this layer would be developed or will own what within the organization, that is the first step. And then building on top of it independently, each domain would work on it, governance, security, and all of this will fit in very well. And implementation of this could be called as a data mesh architecture. It is growing very popular among a bigger, larger organization who has many companies widespread across organization, and they want to understand details or understanding about different layers of it. So that is a data mesh architecture. So time for questions. This is a question which I would like to understand the interest from the user. Which data architecture would you like to know more about? Like, is it the talk about the data lake or data lake house or data mesh, or if there is any other architecture which we did not cover, please specify.
Yeah, and looks like we already have results. So like half of our audience interested in data lake house, 50%, 26% data mesh, and 19% data lake.
Okay, okay. So yeah, so just to like, it's not a surprise. Like data mesh and data lake house has an inbuilt data lake. So the understanding of data lake is very very important. But data lakehouse, that is the beauty of this different architecture with respect to data. We are talking about independently. It When we talk about data domain and data mesh, like the data domain can be a data lake itself, or it can be a data warehouse system, but the interface need not it should not be different, because you are like publishing a data in a form that can be used across. That is why all of these pieces work in over here. And I think this was yeah, this is what I had in my mind to discuss today. Thank you so far for listening to me. Hope you got some of the details or understanding. I'm open for questions and answers now.
Yeah, so we have also questions. Uh, yeah, which of these approaches is more expensive to develop?
Uh, Cost is I would say expensive. Data mesh involves a lot of components. Like it is an we are talking about different components in data lake. We talk about one layer or architecture which has principles which are integrated across. Data mesh can be in different cloud or different layer depending on, as we talked about, like, it's for bigger organization, and if they have a need, uh, assume that an organization has 20 or 50 different subsidiaries. The challenge would be all of this organization, different organization or acquired subsidiaries can have data in different formats, different shapes. So you're trying to unify that. It would be surely expensive to build and manage those, but it is the absolute need. So the question would be, what is the organization gaining out of that? What is it is driving a business, or it is improving a customers. You are getting business out of this data. You're not doing it just for fun. So depending on how much you are driving the business, your cost and expense could be managed. But yet, just to answer in short, data mesh would be more expensive. Data lakehouse could also be expensive depending on the pricing or the model that it could be. But data mesh, I would say it would be surpassing all of those.
Yeah. And also in your diagrams, you mentioned many AWS resources, many AWS services. Yeah. Does it mean that to to develop this architecture properly, I need to learn all of them, and or maybe, for example, yeah, maybe there, or for example, there are ready to use solutions maybe on marketplace.
Yeah, so data lake would be very, very specific. So you can't pick a tool. It's a combination of multiple such tools. Like we have a data catalog. There can be a solution separately for that. You are talking about data security. Either you can use the cloud that provides that service, or you can build it on its own. So most often you it's a combination of multiple platform or tools. It's not only one tool that will give you a data lake. Not just by dumping the data in S3, it's not a data lake. You're just storing the data. It's just one part of the problem. The compute or the analytics integration is another way. Then the access and management. So each of these are different layer. uh, as each There can be different team in within company or org who can manage those. So, and one user or one person who would want to who can manage all of those could be a challenging thing, but it is not impossible. It is possible, but it will be more of a responsibility because your access pattern or the platform, the idea is you are trying to integrate or ingest various set of tools, and you will need to work on ETL processing and all of those. Having more responsibility on other layers could be more challenging. So you need not be, you can be an analytical expert who are using the data as a data platform. You can store the data, make access management, making sure the self-service platform is done, and then your job is done. You're democratizing your data, which means you are not taking the responsibility as a data platform. You're giving the responsibility to analytic thing, like you have access, you execute the query, you analyze that data.
Mhm. Yeah, and also we have a question from Andrei. Which AWS tool is best for establishing data governance process in data lakehouse and or data mesh?
Yeah, so AWS specifically in for lakehouse and mesh, AWS Lake Formation is one service which is catered for building data mesh and data lake kind of architecture. The Lake Formation is focused on these the accessing federation and all of this layer, which is a core purpose for building data mesh, as we talked about. So along with the data integration, so in AWS you can say data catalog, along with data catalog, glue data catalog and lake formation, the integration and how do you channelize those, so you can manage that access permission to a granular level, not only the database level. You can have till table level, uh, column level. You can even have row level access management in lake formation, which is which is what we want to build.
Yeah, thank you very much, Shiva, for your presentation. Looks like we have more questions. Yeah, please connect. Try to contact Shiva directly, I think.
Yeah,
Yeah,
as I mentioned my LinkedIn ID. The intention is to, uh, if if you have any queries, I'm very active in this social media in LinkedIn, so you can reach out to me in case I can help you out in any way.
yeah. Thank you, Shiva. Yeah, so we have a short break, 4 minutes before next speaker, Pavel Goncharenko, who will tell us about data analytics world.
Thank you.
Yeah,
Thanks a lot for
stay
joining.
tuned. Yep.
Stay tuned.